All right, geometry benchmark 3-2 triangle similarity conditions. First problem we're going to look at, and we see we're missing a side. I need two angles, or I need three sides, or I need two sides and an angle. I definitely need another side. So I'm looking at this side here, and I'm going to use the Pythagorean theorem and do 15 squared minus the 9 squared to give me this ED squared. When I solve that, I'm going to get 12 for that side. You can also think of it as a Pythagorean triple. It's basically a 3, 4, 5 triangle multiplied by 3. So, and then I set up the ratios. And if I do the longest sides, basically the 10 and the 15, divide that out and see what I get. That's 2/3, so it's 0.6 repeating. If I do the next longest side, the 8 and the 12, look at the same answer. And I need all three sides if I want to use that one. So I'll do 6 divided by 9. I get the same answer. So in this case, if I have triangle MRG, M is the right angle, is similar to triangle E, because E matches up or corresponds to M, right angles. And then R, I guess you could think of it as the wider angle. So F would be next, and D. Now you might have wanted to use that right angle in this problem, and you may. So, well, this problem so far is side, 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 sorry, similarity. If I chose to use that right angle instead of all three sides, I could have done the 8 divided by 12 and gotten the ratio, and on the other side, so that we have this side and this side here, and the 6 divided by 9, and then just the right angle, so if I basically label this as 90 and 90 or mark them equal, then I could say angle M equals angle E. So if I'm setting up a flow chart or a proof, I could do it that way. And then I'd say the same thing, EFD, but in this case it's by side, angle, side. Okay, that would be for this stuff down here. So the original one I did by side, 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 but you could have done it by side, angle, side also. Number 2. This can be tricky, and you gotta be careful on how these are labeled, because in different benchmarks we have different parts of these sides labeled. Sometimes it's this side, sometimes it's that side, sometimes it's that side. So be careful on how they're labeled. I've got this set up, so I guess just randomly pick numbers. This 16, see if it matches up with this 5. So I do 16 divided by 5. I think that's 3.2. And if it's going to work, this 20 and this 4 have to be the same ratio. Oh, that's 5. So those are not the same ratios. So that's not going to work that way. So since I tried it that way, I'll try the other numbers. And maybe on one of the benchmarks or two of the benchmarks, it'll work that way. So I'm going to try 16 and 4. That's 4. And then I look at the 20 and the 5. And that's 4. So I have two sides that have the same ratio. So I have the 20 and the 5 and the 16. I don't want to mark them equal. But essentially I have this one and that one there marked. The ratios are equal. I just need one more thing. I either need the outside sides out here and here, which I don't have, or I need an angle in between, which I do have. So I can label those, because I don't like to label with 3 letters. I'm just going to put a little 1 and a little 2 in there. So I'll say angle 1 and angle 2 are the same. They're congruent. Measurements are equal. And so now I have, if I was setting this up, I'd put circles around these and point to the triangles being similar, because I have side, angle, side similarity. So SUP, now this is kind of tricky how you label these. If S goes here and U is next, well, U is going this way, I have to be careful here. My S matches up with the same angle, basically on the bottom here, versus if it was kitty corner, if it was diagonal, you'd have to flip-flop this. So just be careful with the order of these. So SUP is going this way. It's similar to REP. Okay. And again, be careful because on some benchmarks it might be flipped. Be careful on how the order of your sides. And I used, what did I use? Side angle side? Side angle side similarity. And make sure they, if they are, complete the triangle similarity statement. Name the similarity theorem. Well, this is the side, 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 or the angle, angle, or the side, angle, side. That's this part. The triangle similarity statement is the actual triangle right here that we have to state. So make sure you answer both of those. And if in one of the benchmarks, if they're not, you have to explain why. So again, read the directions. It does say include your equivalence markings. Okay, that means like pretty much my angles, because I use this angle and this angle. You might use different angles, and that's kind of what's going to happen in the next problem, because you have choices. Well, especially, yeah, we'll just do this one. If you're looking at the picture, we have parallel lines. Right away, when you have parallel lines, you have corresponding angles that are equal. So I could mark those angles equal. I could mark those angles equal. But you need to mark them somewhere so I know what you're talking about. And those angles in the triangles, if you think of the larger triangle versus the smaller triangle, you don't really have to redraw this, but I'm just kind of showing you so you understand. There's a large triangle from here all the way down there. And then the small triangle is right here. So D, E, A. And that actually is going to help us to write the congruent statement. So AED, from A to E to D, in the first one, now that's the small one, so I have to go to the large one now. So ART. And please continue to put the triangle symbol there, because it could be angle ART, so just make sure you put that there. And I used angle similarity. Okay, and my markings are in the picture. You could have, I'm going to erase this. In fact, I'll erase it all. You could have used this angle here, because in the large triangle, small triangle, that angle A right here is the same exact angle, it's just on top of itself. So I know that's congruent to itself. And then I could mark whatever other angle I want to use, this one, and do the same thing. So AED and triangle ART by, again, angle similarity. But again, I have different markings. And I could have used, instead of the T and the D, I could have used the E and the R, or the R and the T. And then this last one, again, we have choices. Because of the parallel lines, we can use alternate interior angles here. We could also use alternate interior angles there. Now, because they're in opposite directions, like the Z thing, it's going to flip the triangles around when I put the order. So HYV goes this way. H matches up with M, if you notice the double line there. Y is a single slash, so that's D, and then V. And I used angle similarity. Now, someone else doing the same, I'll leave the same answer there, might have marked the picture differently. And they might use vertical angles. Angle 1 and angle 2 are equal also. And they could have used either of the other two. If I use H, I have to use M. Be careful on that, it's kitty corner. Unlike our last problem, where it was like the same, like instead of H and D, it's alternate interior angles, it's the opposite angle. It's like the angle of that Z that are equal. So someone could have marked these two angles equal, and by angle similarity. Oops, forgot the little similarity symbol. That's it.